What is right now, at this very second, something far more intelligent than us is watching every move we make, watching us build our cities, launch our rockets, split the atom, and scroll through our phones, not to make contact, not to say hello, but simply to observe, like we observe animals in a zoo. That idea, as unsettling as it sounds, is not science fiction. It's an actual scientific hypothesis that some of the world's most respected astrophysicists have taken deadly seriously. And today, we're going to go deep into it. Let's start with a true story from 1950s New York City. One night, across multiple neighborhoods, people started noticing something strange. Their trash cans were disappearing. Not one or two, dozens of them, vanishing overnight with no explanation. People filed police reports, theories spread fast, and then, around the same time, separate groups of people across the city started claiming to see strange, unidentified objects in the sky. Boomerang-shaped crafts, silent, moving in ways no aircraft of that era could. The media connected the dots, probably too quickly, and a cartoon appeared in the New Yorker magazine showing aliens sneaking around at night, stealing garbage cans off the streets of New York. It was funny, but it sparked something far more serious. At that same moment, in Los Alamos, New Mexico, a group of the most brilliant scientific minds in the world were having lunch together. One of them noticed that cartoon, and it triggered a question. A deceptively simple question that would haunt scientists for the next several decades. That man was Enrico Fermi, Nobel Prize winner, the chief architect of the Manhattan Project, the program that built the world's first nuclear weapon. And the question he asked that afternoon was this: if the universe is 13.8 billion years old, if there are hundreds of billions of stars in our galaxy alone, and if the basic ingredients for life are among the most common elements in the entire cosmos, then where is everybody? Why haven't we seen a single alien? Why hasn't anyone made contact? Why is there silence? That question became one of the most famous puzzles in the history of science. We now call it the Fermi Paradox. To really feel the weight of the Fermi Paradox, you have to understand just how ordinary we are. Life on Earth is built from 5 elements: carbon, oxygen, hydrogen, phosphorus, and nitrogen. These are what make up DNA, the molecule that copies itself, that passes information forward, that makes you, you. Now here's the thing, those 5 elements are not rare. They are among the most abundant elements in our solar system, in our galaxy, and in the observable universe. The raw materials for life are not special. They are everywhere. And the Earth itself? Not particularly unique either. Thanks to NASA's Kepler Space Telescope and other missions, we now know that roughly 1 in 5 stars has at least one planet orbiting in what we call the Goldilocks zone, the distance range where liquid water can exist. Not too hot, not too cold, just right for life as we know it. Now, do the math. There are an estimated 400 billion stars in the Milky Way alone. Multiply that by 2 trillion observable galaxies. You get a number with 22 zeros behind it, and the universe has had 13.8 billion years for life to evolve on all of these worlds. Our own Earth is only 4.5 billion years old. Life appeared here just 3.7 billion years ago. The first fish crawled onto land 390 million years ago. Dinosaurs ruled for hundreds of millions of years and then vanished 65 million years ago. Modern humans have only existed for about 300,000 years. Here's what makes this truly mind-bending. In the last 200 years, we went from horse-drawn carriages to launching robots into the subsurface ocean of Jupiter's moon, Europa. 200 years out of 13.8 billion. Now, imagine a planet somewhere in this vast universe where intelligent life evolved just 300 million years before us. Just 300 million, a blink in cosmic time. Where would they be by now? What would they look like? What technologies would they have built? Their intelligence compared to ours might be comparing a human to a spider, and that's probably being generous. So, where are they? After Fermi asked that question, the scientific world essentially split into 2 camps. The first group said, "We just haven't looked hard enough. They have to be out there. We need to listen." The second group said, maybe we'll never find them, and there might be a very good reason for that. The first group launched SETI, the Search for Extraterrestrial Intelligence. In 1960, astronomer Frank Drake pointed a radio telescope at the sky for the first time in history and began scanning for unusual signals from nearby stars. Radio waves were the logical choice. They travel millions of light years, they pass through Earth's atmosphere, and, importantly, we humans have been broadcasting them ourselves for over 100 years. Our TV shows, our radio transmissions, our military signals, they've already reached over 1,000 stars. If anyone was listening nearby, they know we exist. In 1977, a SETI researcher picked up a signal so unusual, so unlike anything ever detected before, that he circled it on the printout and wrote a single word in the margin: "Wow." That signal, now known as the WOW signal, came from the direction of Sagittarius, lasted 72 seconds, and matched almost perfectly what scientists would expect an alien transmission to look like. It was never detected again. Project Phoenix, running from 1995 to 2004, surveyed 800 nearby stars for radio signals. Nothing conclusive was found. The Breakthrough Listen project, launched in 2015 with nearly $100 million in private funding, has been the most comprehensive alien search in history, scanning millions of stars using the world's most powerful radio telescopes. Results are still coming in. We have sent our own messages into the cosmos. In 1977, the Voyager spacecraft carried the golden record: 108 images of Earth and humanity, greetings in 55 languages, and the sounds of our world into interstellar space. It's still traveling. But despite all of it, we have no confirmed signal, no unambiguous contact, no definitive proof that we are not alone. Now this is where things get genuinely strange. The second group of scientists, the ones who accepted the silence and tried to explain it, came up with ideas that are harder to dismiss than you might think. In 1973, Harvard astrophysicist John Ball published a paper proposing what he called the zoo hypothesis. His argument was elegant and unsettling. Think about what makes a good zoo. Not just any zoo, a perfect one. The animals inside don't know they're in a zoo. They think they're living in the wild. Their environment is designed to feel natural. Their behavior unfolds exactly as it would in nature. And the observers, us, the humans, watch from outside without interfering, because the moment we interfere, we contaminate the experiment. Ball asked, what if that's what's happening to us? What if a civilization millions of years more advanced than ours has designated our solar system, our planet, our species as a protected observation zone? What if they're watching every war we fight, every invention we create, every cultural explosion, every moral crisis, not to intervene, but to study, to understand how intelligence evolves, to observe an emerging civilization in its raw, unmanipulated state? And critically, what if their technology is so far beyond ours that hiding from us is effortless? We wouldn't see their ships, we wouldn't detect their signals, we wouldn't even know what to look for. Ball later extended the hypothesis. Maybe Earth isn't just a zoo, maybe it's a laboratory. Maybe we're not just being observed, maybe we're being experimented on. Maybe the conditions of our development, the timing of certain events, the survival of certain species, including our own, have been quietly shaped by hands we cannot see, not for cruelty, but for science, to answer a question they find as fascinating as we find the Fermi Paradox. Can a newly intelligent species survive its own intelligence long enough to join the wider civilization of the cosmos? That version became known as the laboratory hypothesis. Here's something worth sitting with. The world's major religious traditions, the Bhagavad Gita, the Bible, the Quran, all contain versions of the same idea, that something greater than us created us, watches over us, tests us, and will one day judge us, that our existence here is not random but purposeful, that we are not alone. For thousands of years, humans have felt observed, felt guided, felt that this story has an author. The zoo hypothesis doesn't explain religion, but it doesn't completely contradict it either. What if the beings our ancestors described as gods, the ones who came from the sky, who spoke in fire and lightning, who were described as radiant and incomprehensible, were simply entities so technologically advanced they were indistinguishable from the divine?
What if the supernatural was just the natural seen through the eyes of a civilization that hadn't yet invented the telescope? These are not claims, they're questions, but they're questions worth asking. The zoo hypothesis has a rival explanation that deserves equal attention. It's called the Great Filter. The theory goes like this. Somewhere between the formation of a planet and the rise of a spacefaring civilization, there's a filter, a barrier so difficult to cross that almost no species ever makes it through. And the unsettling question is, are we on the near side of the filter or the far side? Think about everything life on Earth had to survive to produce us. A stable planet had to form in the right zone. Non-living chemicals had to spontaneously organize into the first self-replicating molecule, a transition so improbable that some scientists consider it a near miracle. Single-celled life had to give rise to complex multicellular organisms. Life